All right, so I'm going to show you how to set up an injection RTM, just like be injection infusion. And then we'll go into what we would call a wet RTM, where we predefine what we call a charge shape or maybe like a dispensing amount. And then we can simulate the compression of that into the fiber mat. All right. So first of all, I want to introduce a new meshing technique. I think you're already familiar with the boundary layer meshing technique. So I want to represent a new type of meshing technique, and we'll kind of start simple, and then we'll work our way up to this more complex model. So if you kind of like highlight around, you can see that these feature lines aren't only feature lines; they are actually separate geometries. So what I'd like you to do is I'd like you to highlight all of the geometries except for this rectangular one, and we're going to hide all of those. All right, you can highlight those and then right click hide selected. And we'll just start out with this nice, simple box, essentially. And one other thing that you can do, and the only reason I'm going to point this out is because this will also come up when we go into meshing. You can have one object, let's say this is the object that I want to show. I can highlight only this object and then right click, show selection only. I had you go the long way just so you knew how to hide and show things. But that's kind of the most streamlined way to do it. Yeah. So before we do any sort of meshing, we want to make sure that we have all of our interface or all of our module selection in place. So up under the Home tab, we're going to kind of work our way over from left to right, just kind of like what we did in the training. We're going to ignore a lot of the modeling section because most of the modelings can be done through the mesh, honestly, for RTM. But we do need to make sure that we're in the RTM module before we start to do any sort of meshing. And that's going to enable, you'll see like the ply orientation will show up. That will enable a bunch of features that are specific to the RTM process. So now that we have the RTM module selected, pretty much the rest of it is going to be done through the mesh. And then once we're done with the mesh, then we can select what epoxy and what the ply is going to look like as far as like permeability goes. And then we can define our process and ultimately set up the simulation to run. So we're going to move to the mesh section here. We're going to skip over the model tab. We don't need to do, there's like maybe one step that we'll need to do ultimately in the model tab, but we're going to skip over that for now. And we're going to go into the structure mesh tools. Now, RTM is kind of special in the fact that it requires what we call a hybrid mesh style. So the boundary layer mesh style had this sort of approach here, where we had a boundary layer, and then inside of that boundary layer was filled with tetrahedral elements. These tetrahedral elements end up being quite problematic for the RTM solver because when we're thinking about permeability, that permeability is either going to happen happens planar or it happens through the thickness. And if it's happening through the thickness, then we need to make sure that the solver is continuing straight down in a line of elements. And if there's a disruption with these tetrahedral elements are quite poor from a computation standpoint, and they create a kind of like a disturbance in the solver. So instead of using this boundary layer meshing style, we're instead going to use a more of a structure mesh style where we can create let's say a surface mesh of some sort up here, and then we can create a surface mesh of some sort down here, and then we can just extrude or loft or whatever that surface mesh from one surface to another surface. And what that does is it creates a perfectly regular meshing style. So you can almost like follow one layer of these elements all the way from the top, all the way down to the bottom. In this case, is a runner leading down to the boundary layer mesh of the part. But this is the style of mesh up here that we're going to be creating. All right, and for that, we're going to go into what's called the structure mesh tool. So up until now, you've pretty much just used like the seeding and parameter, define the surface mesh size and the boundary layer meshing layers and stuff like that. But for this style, we're going to use the structure mesh tools. Okay, so what we're going to do is we're going to create a surface mesh on this top surface. Then we're going to duplicate this surface mesh down to the bottom surface. And then we can just create a solid mesh between those two by just kind of extruding the top mesh to the bottom. As far as the surface mesh goes, what you've seen so far is a triangular surface mesh pattern, but we can actually create a quadrilateral surface mesh pattern. So if I go into any sort of mesh parameters, the curve mesh parameters for the runner actually had that quadrilateral style. And we're going to do a similar thing, except for a rectangular surface. That quadrilateral style will actually just look like a grid. Um, and that's the approach that we're going to take. If we can get a quadrilateral surface mesh, that means that we can extrude that to create hexahedral elements, which are the highest quality elements that we can possibly have for computation. All right, so we're going to go ahead and seed this. So we're kind of going to work our way from left to right, and I'll introduce the different sections here. So the leftmost section is creating the surface mesh. The second section is editing the surface mesh. If I wanted to change the element array, or if I wanted to fix the quality of the elements, we could do that here. Then we have editing and creating the solid mesh, and then some checked features if I need to. Let's say if I have multiple blocks of solid mesh, which as a spoiler, we will have multiple blocks of solid mesh. If that's the case, then we will need to check to make sure that all of those are aligned with one another before we can export. All right, so we're going to start all the way on the left side, and we'll go into seeding. We're going to apply a node seeding to our entire geometry. All right, so we're going to hit seeding, then select the polysurface object. So you can just left click on the part, check mark. All right, so it's going to give us the default mesh size. You can hit apply, just see what that gives us. Zoom in, and we want about 2 to 3. You can open this up a little bit more for this hexahedral style. We get a much lower number of elements, just because, like, for example, a 5-layer BLM, there's 11 layers through the thickness. Ultimately, there's 5 layers on the top, 5 layers on the bottom, and then 1 layer through the thickness, or 1 layer of tetra elements. But in order to get that style, we need a tetra layer, which usually has quite a bit more elements than something like a hexahedral style. So actually, you can afford to make the element size a little bit larger than you typically would for a boundary layer mesh, but we're still going to follow that same approach for this model specifically, and then maybe we can make some edits down the road. So I'm going to reduce the mesh size to, let's say, 1. That's a little bit too large still. We'll go like 0.75. Yeah, I'd say 0.75 looks pretty good. All right, so I'll use this mesh size. It's actually pretty important to remember this number, particularly because we always need this, whatever mesh that we create here, we need to match that to the rest of the geometry around it, right? So if we were just doing the mesh for this box, then maybe this number wouldn't matter as much. But the fact that we need to ultimately match that to the mesh that we're going to create for the rest of the geometry, we need to make sure that we apply the same mesh size. All right, so you can go ahead and press the green check mark, and that's going to send us into manual node seeding. Now, in boundary layer mesh, we usually don't use manual node seeding too much, just because we want the surface mesh to be as uniform as possible. And the same applies to this type of meshing. Actually, it applies even more so in this type of meshing, that we want the node seeding to be uniform. But like I mentioned, what we're trying to do is create a series of quadrilateral elements across the top surface here, and it should ultimately look like a grid. And in order to get that grid pattern, we need to make sure that the number of nodes on the left side of the part is equal to the number of nodes on the right side of the part. And we need to make sure that the number of nodes on the top side is equal to the number of nodes on the bottom side. All right, so what we're going to do is we're going to highlight the edge on the left side here. And we're going to note how many segments are on that left side. In this case, it's actually a nice even number. We got 40 nodes. On the right side, we also have 40 nodes. That should be the case for a rectangular surface like this. We should always have the same number of nodes if we have the same node seeding. But for more complex geometries, let's say this edge was longer than this edge, it's very possible, because we're using a uniform node seeding, it's very possible that the number of nodes over here is not equivalent to the nodes over here. So we always need to make sure that the number of nodes are equivalent so we can get that quadrilateral surface mesh array. And so if they're not equivalent, let's say this side had 45, what I can do is I can just highlight the edge that I want, that I have over here, and then I just change the number of segments to be that number. I'm going to change this back to 40 because that's what we had. So we have 40 nodes on the left side, 40 nodes on the right side. Those are numbers to take down as well. So we noted that we had a 0.75 node seeding. We also want to note this number as well, because this edge is going to line up with the edge of the geometry around it. And we're going to need to make sure that that node seeding is equivalent. On the top side, we have 67. Let's make that a little bit more even. Let's say we'll do 70 on the top and 70 on the bottom. It's very important that you make sure that you're selecting this top surface, the top surface edge. So when you're rotated like this, sometimes you can accidentally grab that bottom edge. You always want to make sure that you have the top edge instead of the bottom edge, because the top surface is actually what we're going to be generating. So another way, and this is more of just so that you don't have to worry about top surface, bottom surface, is you can just select all of these feature lines, right? You can just select all 4 feature lines using a right to left box select. I can just select through all of those feature lines and it'll select all of them. And then I can just define the number of segments for all 4 of those feature lines simultaneously. All right, so we have 70 segments on the top surface, 40 segments on the side surface. And that's actually all we need to worry about. So we can go ahead and press the green check mark. That will get us out of that seeding function. And then we're going to go and create the surface mesh for this top surface. All right, to do that, we're actually just going to move just to the right of the seeding function. And there should be, I think the default button here should be create face mesh. All right, there is a dropdown. So there's a couple of other functions under here. Actually, one of them we'll use in just a moment, the map to face. We're going to map this surface mesh to the opposite face, but we need to create that surface mesh first. So let's go ahead and hit create face mesh. Now, before we select anything, it's very important to note these two checkboxes. Actually, really only the one checkbox on the top here, mixed element, quad element, dominant. So what this does is it's going to try to create quadrilateral elements wherever it can. And being that we set up the node seeding the way we did, we are going to enable this to create only quadrilateral elements. If we uncheck this, then it's going to use the triangular mesh. Okay, so very important. You want to make sure that this is checked. There are situations where the geometry is complex enough to where quadrilateral elements are not possible. In that case, you could uncheck this box and just create triangular elements. Triangular surface mesh elements aren't necessarily bad, but if you think about a quadrilateral element, you would need to divide that in 2 to create 2 triangular elements. The element count for a triangular mesh element array is double that of a quadrilateral element array. So this is just going to help to make sure that the solver is as efficient as possible. But like I said, as far as the solver is concerned, the fact that we have a perfectly regular array of elements through the thickness is the most important thing. And so whether you have triangular mesh array or quadrilateral mesh array, the solver will be okay with either of them. Just the quadrilateral mesh array will be more efficient. So in this function, what we're going to do is it's asking us to select faces. So we're just going to select this top surface. It'll turn it from gray to orange. All right. And then with the mixed element, quad element dominant checked, you can go ahead and press the green check mark, and that will create our surface mesh. All right. So that's kind of the hard part is creating the face mesh. The easy part now is duplicating this surface mesh to the bottom and then creating the solid mesh between the two. All right, so in order to copy this surface mesh from the top to the bottom, there's a couple of ways to do it. I could actually just highlight this surface mesh, right click, copy selected, and I could just copy this mesh from the top to the bottom. However, and in this situation, because it's a perfectly regular, or the top surface is exactly the same as the bottom surface for the entire geometry, then that approach would work. but it's not always guaranteed that that's the case. It could be that maybe the contour of this surface isn't the same as the contour of the bottom surface, or maybe it's the bottom surface is a little bit larger than the top surface. So the more consistent approach is actually to use the map to face. All right, so what this is going to do is it's going to take this surface mesh and you're going to represent a few different references that would allow this surface mesh to be mapped to this face. So the first thing, we're going to select a few things. So the first one is the mesh that we want to map, which is this top surface. You'll see that we'll select in orange. And so the second thing that we're going to select is the surface that we want to map to, which is the bottom surface. And so now, so it should kind of isolate these two objects, the mesh and the surface. And so now what we're going to do is set up a series of references. So you can kind of rotate around to your first reference, and you can know that by where the red line is connected to. For a rectangular surface like this, we're going to have 4 references. It's possible for a more complex surface that you have more than 4 references. But in this case, we're going to have 4 references for the 4 corners of our geometry. And what we're telling the mesher is what feature on the surface that we're trying to map to matches to the mesh that we've already created. And it usually goes in either clockwise or counterclockwise direction, I guess. And so you'll just set up all 4 of those references. So you can go ahead and press OK, and you should see that it just maps that surface mesh from the top surface down to the bottom. Okay, so now we need to create the solid mesh between these 2 faces. All right, so we have the top face, we have the bottom face, and so now we just need to define how many layers we want between these 2 faces. To do that, we're going to skip over the edit surface mesh. We don't need to change the surface mesh at all. We're just going to go into the create edit solid mesh. And the first function in there should be create by 2 faces. Okay, so we'll go ahead. That's the function that we're going to use, create by 2 faces. You can go ahead and click on that. So once again, it's going to ask you for a few things. And it's actually kind of similar in the sequence as what we did for the map to face. We're going to select the start mesh, which is the top surface. So start mesh is going to be the first mesh. End mesh is going to be the other mesh. All right. And then mesh nodes, what it's going to ask you to do is select 3 nodes on the top, on the first mesh. And then you're going to select the exact same 3 nodes on the bottom surface or on the other surface. All right, so what that's going to look like is I usually use the corner just because it's easier to identify. If I use somewhere in the middle, it's going to be difficult to find those exact 3 points on this mesh. So usually I use the corner just to make things as easy to identify as possible. And what I do is I usually take 1 point off of the corner as my first point. My second point is the corner itself. And then the third point is 1 point in the other, or 1 node in the opposite direction. All right, so I did 1, 2, 3. And then on the bottom surface, you'll do the same exact thing. So 1, 2, 3. All right, so then down towards the bottom is where we're going to determine the number of layers that we want through the thickness. You can also use by mesh size, but honestly, more times than not, you want to just guarantee a number of layers. You might have a number of layers in mind. Our number that we usually use is 10. We want at least 10 layers through the thickness for RTM. You could go higher than that. I wouldn't go lower than that. From the solver standpoint, you do get a little bit of stability issues if the number of layers is not sufficient through your model. Yep. And once you have that selected, you can go ahead and press OK. No need to do any sort of biasing. We want the layers to be as uniform through the thickness as possible. So you can go ahead and press OK. And that will create the solid mesh. That's pretty much the procedure that we're going to use for the rest of the geometry. So we can create the top surface mesh, duplicate that to the bottom surface, and then just create the mesh through the thickness. All right, so now, generally speaking, I like to have the solid mesh in a different layer as the geometry. And that's more for visibility and the ability to kind of hide and show things easier from the model tree. You can see that we have a couple of new objects we have the surface mesh, we have the surface mesh with this icon here, which represents solid mesh. I don't know why they call it surface mesh. Actually, it is solid mesh. So what I like to do is usually attribute this solid mesh as a part, so that I can separate this in the model tree. Because right now everything's non-attributed. If I attribute it as part, now it shows up in a separate section in the model tree. All right, so you can go ahead and we're going to right click on this. You can highlight it either from the model tree or by just clicking on it. Make sure you have the solid mesh selected. Okay, once you have it selected, you can right click, edit attribute. Yep, and then you can just change that attribute from none to part. Because we're in the RTM module, when we assign the part attribution, it's also going to look for a ply attribution. Ply is a way for us to discern the different fabrics or the different media for the resin to, or for the epoxy to flow in. If I have an open mold with some fiber mat, then I'm gonna have two plies. I'm gonna have one ply for the empty air, so the material can flow much more fluidly through the air, and then I'll have another ply attribution for the fiber mat itself. So now, what I want to do is I want to extend this mesh to include the rest of the geometry. All right, so we're gonna bring back. Let's go ahead and bring back everything. You can do that by just turning off the non-attributed main radio button here and then turning it back on. That will show everything. So what we're going to do now is we're going to create the surface mesh or we're going to do a similar extrusion method for this side of the part. And then we can move to this side of the part, and then we can worry about this kind of middle section. All right, so what I'm going to do is I'm going to isolate this object here, the larger object. And the way to do that is I can just left click on it to select it. And just like I mentioned before, you can either go through the model tree and turn off everything that is not the selected object, or once it's selected, you can right click, show selection only. That will isolate that. Now this next part is going to be a little bit tricky. In order to create the rest of the surface mesh, we have to do it in blocks. So when I say we have to do it in blocks, what I mean is, let's say I want to go from this corner, or let's say I don't want this middle portion. So let's say I want to create the surface mesh for this kind of like C-shaped surface. Unfortunately, I can't do it all in one go. I have to break this into different sections. And the reason for that is because I have this rectangular cutout that has some nodal array. If you remember, we had 40 nodes on the top and then 7 on the side surface. I need to guarantee that this nodal array matches up. And in order to do that, I have to do this in sections where this section has the same nodal array as what we have connected here. And then this section here has the same nodal array that I have connected here. And then these two corner pieces will just be kind of matching, I guess, to this piece and this piece. All right, so we'll have to do this in 5 sections. We'll have to cut this into 1, 2, 3, 4, and 5. All right, so we have to divide this surface into different sections. And there's a nice tool that allows us to kind of embed or section off different regions of a surface. In order to do that, we're going to have to draw some lines. So what I'll have you do is go from the structure mesh tab over to the tool tab. The second operation, or the second drop down over to the left, the first thing in that drop down should be a line. So in order to do this line drawing, we're going to have to set up a bunch of references for ourselves, which isn't too difficult, but it does require us to have some snaps activated. All right, so ultimately we'll have the 4 snaps active. We have end, midpoint, mesh, and perpendicular. Those are the 4 that we'll have toggled on. And that'll pretty much follow suit for the rest of this modeling. All right, so going into the line function, the first line that I'm going to create is from this corner here. All right, you can left click there. And then the second point, we're going to make sure that that perpendicular snap comes up. All right, and then you can click again. We're going to do the same thing for the bottom side. And there's actually a point of efficiency. You can hit the space bar and that will repeat the last command that you did. And so when you're drawing a bunch of lines, you can just draw the line, space, draw the next line, space, draw the next line. Okay, so we have 4 more lines to draw. So we drew these 2 lines. We have 4 more to draw. We're going to draw a similar set of lines on these corners, up perpendicular to the top and bottom edges of this geometry. And then we'll go over to the side surface. Awesome. So now so these lines are completely independent of the geometry. And so we need to divide this top surface using these lines. And we can do that using under the edit section. You're going to click on the more dropdown, and we're going to use the divide face function. Okay. So the way this function works is we're going to select a surface to divide. That'll be the top surface here. That'll select in orange. All right, check mark. All right, and then it says select curve. We're just going to actually box select all of the curves that we just drew, and then check mark. So now this is a part that actually trips me up a lot. Whenever you make any sort of edit to the geometry like this, it resets your node seeding. Now, we would always be going into the node seeding function anyways, but it's always good to not make any assumptions that the node seeding is the way that it was in the previous geometry. Okay, so that being said, we're going to go back to the structure mesh tab. All right, and we're going to define the node seeding for all these features. So you can go ahead and hit seeding, just select the polysurface object, check mark, and now it's going to force you to create a new global mesh size. So we'll use the 0.75 mesh size, apply. So check mark. All right, and now in the manual node seeding, this is where you spend a little bit of time, honestly, because we need to make sure that the nodes on this surface or on this edge match with the nodes that the solid mesh that we already created. So this edge needs to have 40 segments. Because this edge has 40 segments, the opposite edge on this surface also needs to have 40 segments. Yep. So we need this one, this one, this one, and this one to all have 40 segments. And we're going to do the same for this. So we want 70, and it says 67 right now. So we'll go ahead and change that to 70. Right, but that's not the end of the road, because we also have to worry about this direction and this direction, as well as this direction. Right, so we have a number of nodes that matched in this direction. We saw that was 40. We also need this number of nodes and this number of nodes to be equivalent so that there's a grid pattern of surface mesh on this surface. We'll go ahead and just make it a little bit tighter. We do that same thing for the bottom here. All right, and then we also want to make sure that all 4 of these feature lines have the same node seeding as well. And in fact, should have a nice number here. All right, so once you have all of those seedings applied, you can go ahead and press the green check mark. And then from here, it's all about just creating the surface mesh. So next to the seeding function, you can click on the dropdown and go to create face mesh. And the nice thing is you do not have to go through these one by one. You can select all 5 of them at the same time. Hold the shift button to multi-select. Right, and then you can press the green check mark. All right, and now hopefully you should see that everything is quadrilateral. Now, in the previous geometry, when we created this solid mesh here, What we did is we copied the mesh from the top surface down to the bottom surface. But in this case, the bottom surface is not equivalent to the top surface. And so in order to map this surface mesh here to the bottom surface, we have to create those references once again. But we don't actually have to create all of them. We only have to create the references of the boundary of where the surface mesh ends. So we have 5 blocks of mesh. We can just consider this as one continuous mesh. And actually, we will eventually merge all of these meshes together. So actually, instead of creating all of the feature lines that we did before, we're only going to create 2. I'm going to go to the Tool tab, Line, and we'll go from here, perpendicular on the bottom surface here. We'll go from this corner perpendicular, and from, show it with that mesh snap, this corner perpendicular. So what we'll do, first of all, we need to extract this surface mesh from this solid body so that it doesn't get removed when we go into that divide face. All right, so we're going to use the extract mesh tool. And then it asks you to select mesh objects to extract surface mesh from. And we're actually just going to select the entire geometry, not just the mesh, but we're going to select the entire, it's going to highlight the wireframe of the geometry and press the green check mark. Okay, so now what this does is it'll create an actual object over in your model tree. You should see a new surface mesh. And so that will be this non-attributed surface mesh. If you click on the mesh, you can probably see that there's 2 surface mesh objects now. You go ahead and highlight the surface mesh attached to polysurface, and then you can delete that one. So we're going to right click, delete selected, and that should bring back your surface model. All right, awesome. So we have those 2 lines drawn, right, on the bottom surface. And so we're going to use that divide face one more time to separate this surface from the rest of this bottom surface. All right, so we're going to go back to the Tool tab. So we'll go Tool, then under the More dropdown, Divide Face, and we're going to select this top surface, check mark, and then you can select those 2 curves. You know, use the Shift Select, or you can select the 2 latest curves or the 2 highest number curves over in your model tree. That will embed those as feature lines. All right, so now we have a surface that we can map the surface mesh that we created on the top side. We can now map this surface mesh to the bottom side. So we're going to go back over to the Structure Mesh tab, and then we're going to use the Map to Face. If it shows us Create Face Mesh, you can click on that drop down and go to Map to Face. So we'll go ahead and select the mesh, and then we'll select the surface on the bottom side. And now because this is a slightly irregular surface, it'll probably force us to do more than 4 references. Before we did 4 references for the rectangular surface, but now maybe there will be 8 references, I think. So you're just going to work around. So it says 8 sets of points. You can go ahead and press OK, and that should create that mapped surface mesh. So now we're just going to create the solid mesh between those 2. So we're going to go over to the Create by 2 faces, and then we're going to select the top surface and bottom surface, and then just like before, we'll select 3 points on the top and then 3 points on the bottom. We absolutely need to make sure that the number of layers is consistent in the same plane of mesh or in the same plane of the geometry. So we need to make sure that the number of layers is 10, and then you can press OK. And it should create the solid mesh. All right, now the reason that I have this cutout separated from the rest of the geometry is because this would be, in this situation, we're going to consider this as a patch of different fiber mat than the rest of the geometry. So let's say most of the geometry has some fiber mat layout, but then they cut out this rectangular area and put a different fiber mat array in this area. So this area would be 1 ply, as we just attributed up here. Area out here would be a 2nd ply. So let's go ahead and attribute the solid mesh object. We're going to find the solid mesh, right click, edit attribute, and then we can change the attribute to part. Yep. And then we're going to create a new ply group. So you can hit add, create ply 2. But we want to make sure that we create a new material, because the material is what we're actually going to end up selecting when we actually go to set this up to run. Under this dropdown, I'm going to hit add one more time. So we hit add to add this ply group. Then we're going to add a second time to get a new material. You can change the color if you want to. So you can see that the color here is actually interactable. You can change this color to be whatever you want to. I'm just going to keep it as the lime green, but if you want to change that, go ahead. Right, and you can actually call this whatever you want to as well. Some technical name for the fiber mat that you're applying, then you can change it to that just to make it a little bit more straightforward when we go to actually assign the material property. You can press OK, and then you're going to select material 2 under the dropdown. All right, and then we're going to click OK one final time to create that material, and then we're going to select material 2 under that dropdown. So you should have ply 1 and ply 2. Okay, so now we're going to handle the other side. So we're going to work actually the opposite way on this side. So on the left side here, we created the cutout first and then created the mesh around it. We're going to go the opposite way for this side. We're going to create the kind of outline surface mesh first, and then we'll create the solid mesh for the cutouts later. All right, so first things first, we need to divide the surface so that we can isolate this side from the rest of the geometry. And the reason we'll need to do that is because ultimately we have we have this guy in the middle, and we'll need to create a kind of like a mesh that would match for this object specifically. So we'll handle that a little bit differently. But just so you know, we'll have to isolate kind of this central region for that instance. All right, so in a similar way to how we created the isolation over here, we'll create some lines, and then we'll divide the face based on those lines. And the nice thing is for this geometry, because they're kind of all in the same line, we pretty much only need one line to divide the face. We just need to go from here all the way. But we're actually going to have to create 2 lines because there is no reference that occurs right here. So we have to first create that reference, and then we can draw the line. All right. And we can actually do that pretty easily. So if you go to the Tool tab, all right, we're going to draw a reference line. So we're going to use the line function. And I'm going to go from the top corner of one of these cutouts up to perpendicular to the top outermost feature line. We're not going to use this line for dividing the face. We're actually only using this line to establish a reference right here. And so now we're just going to draw a line from this point, this end point of the line that we just created. We're going to draw that all the way down perpendicular to the bottom feature. All right, and now we're just going to use that divide face function one more time. So we're going to go under the edit section in the tool tab. We're going to go edit more and divide face. All right, select the face to divide. It's going to be this guy over here. Check mark. And the curve is just going to be that one curve and check mark. Now, just to avoid or to maybe eliminate that occurrence that we had over here, where we had to kind of like copy the mesh, because we have that foresight, let's go ahead and do that divide face one more time for the bottom surface. Now, I could do the same thing. I could create the 2 lines on the bottom surface the same way I did on the top. But since I have this line, what I could do is actually I could copy this line from here down to the bottom surface perpendicular. Since this is an extruded geometry, you won't always be able to do that. So it might be more consistent to to create the lines again. Let's go ahead and highlight this line here. Right click, copy selected. Yep, your reference point is going to be the end point of the line, and then you're just going to find the perpendicular down to the bottom surface. Yep, and then we're going to do that divide face again. More divide face. Select that surface, check mark, line. Now, unfortunately, that's not the end of the road because kind of like what we did over here, You can't just have the one divide face. You have to do that for all of these corners as well. First of all, um, there's a couple of ways that you can go about this, but I think just drawing the lines is probably the most efficient way.
Okay.
You could, like, for example, I could copy this line over to here, and then I could draw the rest of my references off of that. But I think it's a little bit too convoluted. So what I'm going to do is I'm just going to go line to the edge, line to the edge, line to the edge. Effectively, we need to be creating this surface mesh in rectangular of surfaces as we possibly can. Cool. So we can do the divide face. So edit, divide face, select that surface that we just separated from the rest of the geometry. And then we can select all of those curves. You can actually box select all of them, or you can select them from the model tree. Awesome. So now let's go ahead and seed this. Yep. So let's go back to the structure mesh and then seeding, and then we'll select the entire geometry. All right. Let's go ahead and change the node seeding to what we had before for the left. Also apply that same node seeding, general node seeding to the right side, 0.75. And that will apply for the rest of the geometry. We don't have to worry about what happens over on the left side because that's already generated. We only care about what's happening over on the right side. All right, you can press the green check mark, and that will bring us into the manual node seeding. All right, and we just need to make sure that all of the seeding for all of the opposite surfaces are exactly the same. Because we use the same global node seeding, all of these should be the same. I don't think we need to go in and change everything. So you can just go ahead and press the green check mark, and then we can go and create face mesh, and we'll go in and select each of those surfaces. All right, once you have all those selected, make sure that the mixed element is checked. I always like to make a note of that, just because I don't want to accidentally create triangular surface mesh. All right, if that is checked, you can go ahead and press the green check mark, and that should create this grid. So now, because we divided the face on the bottom side, all we have to do is merge all of this surface mesh together and then map that to the bottom surface. All right, so we'll go ahead and select all of the surface mesh that was just created. We'll use combine, and we already pre-selected it, so you can just press the green check mark. You don't have to select anything. So then we're going to go ahead and map that to the bottom surface. We're going to use the map to face. Mesh is going to be the top, surface is going to be the bottom, and then we're off to the races. So let's go ahead and create the solid mesh through the thickness then. All right, so we're going to use the create by two faces. All right, we're going to select the first mesh and then second mesh, and 3 points on the first mesh and 3 points on the second mesh, just like before. And we just want to make sure that the number of layers is equal to what we had over here, because ultimately this is going to become one continuous geometry. You can go and press OK. Let's go ahead and attribute this. So go ahead and select that solid mesh object, right click, edit attribute, and then we'll change that to part. And then we're going to make this the same ply as the main geometry over here, which should be ply 2. So let's go ahead and move on to the next one, which is going to be these rectangular bars. All right, so let's go ahead and turn on those rectangular bars, which I believe should be polysurface 2, 3, 4, and 5. All right, and then we're going to go ahead. We're going to create the surface mesh. I'm sorry, getting ahead of myself. We'll go ahead and seed those. In this case, we're actually going to hit yes. But interestingly enough, what we did with the mesh that's matching this here, we only applied the node seeding, and then we didn't really adjust the number of nodes. And so the node seeding that we apply, the 0.75, should give us an exact node seeding replica of what we have on the rest of the geometry. Input that mesh size of 0.75, and you can hit the green check mark. I'm going to note the number of segments just in case. We see 0.94. And so just as just kind of like a peace of mind at this stage right here is you can go into the model tree and you can actually turn off the part and then turn on the part, and it will show you the mesh of what we've already created, and you should see that the nodes align perfectly. So you can go ahead and press the green check mark to get out of the node seating, and then we can create the surface mesh. So we'll click on that drop down, go to create mesh face, and then we'll select all 4 of those top faces. And you can hit the check mark, create that face. Yeah. Now we can go ahead and map these to the bottom surface. Now, unfortunately, these are individual surfaces that have to be mapped to individual surfaces. But in this case, we'll have to do them in 4 separate mappings. So we'll go map to face. I'll select this, and we'll just do them in 4 separate operations. Luckily, there's only 4 references for each of these, so it should be pretty straightforward. So if you want to create the solid mesh, you can go ahead and do the create by 2 faces, and then 1, 2, and then 3 nodes on the top surface, 3 nodes on the bottom surface. So now that you have the solid mesh for all 4 of these, you can go ahead and select all of those. You can do this all at once. You don't have to do them one by one. And then right click, edit attribute. And then we can change these to part. Now, I'm just going to assume that these patches, I'll call them, are the exact same ply as this, or the same properties as this patch over here, as far as the permeability is concerned. So I'm just going to call them as ply 1. But if you wanted to, you could always add a 3rd ply, and you could assign the properties differently that way. You can have as many plies in the analysis as you want. All right, so now the middle section. Let's go ahead and turn on the polysurface 6. If you want to, you can get it. You might have like a lot of curve objects. You can either turn those off. Actually, we don't need those curves anymore. So if you wanted to, you could just delete them from the model tree over here. So once we've already created the surface mesh and all that, we don't need them. All right, what I'd like you to do is bring up polysurface 6. It should be the only object that has like this filled in icon now. I'm going to flip over. Actually, you can hide everything except for that polysurface 6. We're going to work through the mesh of this, and then we're going to apply that for the mesh on the rest of the geometry. Now I'm going to flip down to the bottom side of this, because the bottom side is kind of what we're going to have to work with first, and then we can extrude this mesh up to the top, and then we can copy this bottom surface to the rest of the geometry and work from there. So I'm gonna do these in kind of pairs, I guess. I'm gonna work from the center outwards. So what I'm gonna do is I'm gonna hit seeding, and I'll select the geometry. It'll ask if I want to reset. You can hit yes. We'll need to set it to 0.75. And then you can press the green check mark. We have 5 surfaces that we're going to have to create the surface mesh for. 3 of those surfaces are quadrilateral. So this surface here has 1, 2, 3, 4 sides. This one here has 4 sides. This one here has 4 sides. These 2, this one here and this one here, only have 2 sides. Yeah. Whenever we have an interaction like this, we cannot create a quadrilateral surface mesh. And that's not the end of the world. Like I mentioned, triangular elements aren't necessarily a deal breaker. They're just less efficient than quadrilateral elements. But whenever we have a curved surface like this, generally speaking, we don't really have a choice but to create the triangular mesh on these surfaces. But for the surfaces that we can create a quadrilateral mesh, we want to make sure that the node seeding is correct. All right, and when I say that, we're just going to be worrying once again about these opposite surfaces or opposite feature lines. So in this case, this one here and this one here, we have 17 nodes. We don't really care about the correlation between this and this. You can probably see that there's more nodes along the outside, which is fine. Like I said, we're going to create a triangular mesh for this guy over here. So we do not need those to align nodally. What we do need to align though is these the internal surfaces here. So 1 and 2. So we have 15 nodes. Then we also need that to align with the outer surface here. You see it's 14, so we want to change that to be 15. And same thing with the opposite side. All right, you can press the green check mark to get out of there. All right, and then we just need to create our face mesh. Now I'm going to do this in 2 stages, quadrilateral for these 3, and then triangular for these 2. All right, so keeping this box checked, I'm going to select these 3 to make sure that I can create that quadrilateral array. Check mark. You should get a nice, perfectly quadrilateral surface mesh. All right, and then I'll do that one more time, create face mesh. And then I'm going to uncheck the mixed element. I'm going to select these 2 side surfaces. Check mark. You'll see that I'll create triangular mesh. Now, this part can be a little bit tricky. What we need to do, so ultimately we need to create an extrusion, but we need to do it in 3 parts. So we need to do this extrusion from here to here. We need to do this extrusion from here to here. And then we need to do from here all the way to this surface. You know, fundamentally that should make sense. But something that's maybe not as intuitive is the fact that the nodes along this extrusion, the nodes have to align at this boundary. The reason this can be a little bit tricky is because sometimes we have to create it if we didn't have a perfectly consistent cross section. Like for example, if this was a tapered geometry or something like that, then we might have to create another surface that would represent this boundary. In this case, I actually do have a perfectly extruded geometry, so it'll simplify things a little bit. But we do have to do this. This extrusion here is going to be 2 stages. We're going to go from here to this point, and then from this point down to the bottom. There's there's actually another tool that we can use. Up until now, what we've done is we've mapped to face. But there is another tool that we can use for a more simplistic extrusion. And that is under the Create by 2 Faces dropdown, there is a Create by Sweep. All right, so what that's going to ask us to do is it's going to ask us to select a start mesh, which I'm going to start with just one of these guys over here. And then it asks us for a guide curve, which it's basically just an extrusion curve. We will need this curve drawn before we go into this function. All right, so I'm going to exit out of that function. We'll go to Tool, then we'll go to Line. All right, and then we're just going to draw a line tracing this feature line effectively. All right, so let's go back to Structure Mesh. We'll do that once again. We'll do the Create by Sweep. That should be the main button up here now. All right, Start Mesh will be the top, the surface mesh here. Guide curve is the one that we just created. Just like with the Create by 2 Face, it's going to ask us for the number of layers. We'll use 10 here, although this number does not need to be equivalent to what we had over here. You can press OK, and it'll create the solid mesh. Now I'm going to do that same thing for the opposite side. All right, so now this middle section, we're going to do a little bit differently. So we are going to do this kind of sweep style, but we need to do 2 of them, right? So I need to do a sweep from here to here, and then I need to do a sweep from here to here. So before we do the sweep, we do want to combine these meshes because you can only sweep one surface mesh at a time. All right, so we're going to go ahead and combine these. So just like before, we're going to select all 3 of these and we'll use the combine function. So there one surface mesh, and then we can use the create by sweep, start mesh, curve. This one we definitely want to make sure is the same number of layers as the two extrusions on the other side. All right, so now we have a little bit of a dilemma. In order to create a sweep, we need a surface mesh that exists on the beginning of the sweep, and our surface mesh exists up here. Now, luckily, it's not too big of a deal, but we just need to move this surface mesh down to here, down to the bottom of the guide curve. All right, so I'm going to highlight that surface mesh and then right click, and you can do a copy or a move. I usually do a move just because the original surface the original surface mesh isn't really necessary. So I usually just do a move here. All right, and then we'll go from the top of that guide curve down to the bottom of that guide curve. All right, so now we need to draw a second guide curve. We need to go from the surface mesh location up to the top of we'll call it the runner that we're trying to create here. All right, so we'll go tool and line, and then we'll go from, in this case, I want to make sure that I have my mesh snap active because there is no endpoint here. So I will need to use the mesh as my snap point. So we'll go from mesh all the way up to the top of this, which should be either end or perpendicular. All right, and then we'll do a sweep one more time. Create by sweep. Guide curve. The number of layers here doesn't really matter, but I usually like to maintain the density as much as I can. So if you know what this distance is relative to this distance, then maybe you can adjust the number of layers accordingly. I'm going to say that this distance is about half of this distance, although I know it's probably not exactly that. So I'm going to go with 5 layers here. We can press OK, and it'll create that. Now, all right, so this object is going to be our cold runner. And so this area there, this volume would be unfilled in the beginning of the analysis. And there will be no fiber mat in this volume. We're going to do 2 steps here. The first one is going to be, we're going to connect all 4 of these pieces together. Now, when we did surface mesh, that was under the edit surface mesh section, and we used combine. When we have solid mesh, we're always going to be working under the solid mesh section, and under here, there's a join mesh. So let's go ahead and hit join mesh, and it will probably appear that it didn't do anything. But if you click on any of the solid mesh objects, you'll actually see that there are 2, and one of them is the combined. All right, so go ahead and select the combined one, and then we're going to attribute this. We're going to attribute this as a cold runner, so that'll have like this light blue color to it. In RTM, the cold runner is just going to be assumed to be unfilled without fiber mat, and so the material will be able to, or the epoxy will likely distribute along this cold runner first before it penetrates downwards in the thickness direction on the fiber mat. So if we bring back the main poly surface, which I believe should be poly surface 40, and you can bring back the all of the part objects, you can just show the entire part section. All right. So we see that we have the solid mesh for this side, we have the solid mesh for this side, we have the solid mesh for the cold runner. The only thing we need to do left is the solid mesh for this middle section. The reason that we did the cold runner first is because now I can copy the surface mesh of the bottom surface of this cold runner onto the top surface here. I can create the rest of the surface mesh of this surface, and then I can just map that to the bottom side and create the solid mesh. So the first step here is going to be, I'm going to copy the bottom surface of this cold runner solid mesh to the top surface of this geometry. Now, I need to copy the surface mesh of the cold runner onto this geometry, but what I have selected here is the solid mesh. There's a tool that allows us to extract the surface mesh from a solid mesh object, and that is conveniently called extract mesh. And so what that will do is it will duplicate the surface mesh of this solid mesh object. And so now we're going to have in overlaid, if you click anywhere on the cold runner object, you should see 3 objects. You should see that there's a solid mesh of this one piece. There's the solid mesh of the entire cold runner. And now there's this surface mesh object. All right, so now that we have the surface mesh, we're going to use a tool instead of combining surface mesh. Now we're actually looking to separate the surface mesh, which is going to be done through the explode function. And so there's 2 checkboxes. You can extract by mesh, which will force you to select mesh that you want to explode. That's a little bit less efficient. I usually like to explode by feature angle, especially with a geometry like this. We can just say, all right, anything less than 20 degrees or something like that, we just automatically separate. So we'll go ahead and press the green check mark, and the default feature angle, I believe, should be 20. You can go ahead and press the green check mark. And now you should see, if you select that bottom surface of the cold runner, you should see that the surface mesh is all extracted as one surface mesh object. Okay, so that's what we need to copy over to this geometry. So under create surface mesh, we're going to hit copy paste. What we're going to do is we're going to select all of the elements. So it's asking us what elements we want to copy over to that geometry. So we're going to select all of them, check mark, and then it asks us to select what object to assign, and we'll select the main geometry, which for some reason I can't select. I'm going to do it from the model tree. And then you can hit the green check mark to finish that. So what that does is it copies this mesh in place. You should see that you have 2 overlapping meshes now of the same mesh pattern. Surface mesh attached to polysurface, that is now a part of the polysurface 44 in your case. The other one's just kind of like a free surface mesh. There's one more step before we get to kind of like the final steps. So what we're going to do is we're going to create a surface mesh for this entire surface. And then we're going to delete the surface mesh that overlaps with the mesh that we just created. And then we're going to effectively just stitch the 2. So the way we're going to do that is we're going to go to seating. All right, and we'll select the polysurface. All right, it'll say the existing mesh will be deleted. Do you want to reset the global mesh size now? You can hit yes here. And then we will define the global node seating as 0.75. All right, and you can hit the check mark. And then the manual node seating, you could go through and manually apply the node seating to each of these segments. This side should be fine. This side, maybe we would want to let's make this node seating on this surface equivalent to what we had on this geometry, which was 70. And then I believe we changed these ones here, this one and this one. I believe we changed from 34 to 40. And that should be all we need to do. I think all of the node seating on this side should be perfectly fine. The node seating on this side and this side aren't necessarily that crucial. And the reason for that is because we're going to be creating a triangular mesh for this surface, just because we have to match that mesh ultimately to the copy that we did. Okay, now we're going to create the face mesh for this surface. So we'll go and create face mesh. And we will do a triangular mesh array. So we will uncheck this element checkbox. All right, we'll select this surface and press the green check mark. Yeah, I think we have to do that copy paste again. That surface mesh that we copied over got removed when we did the node seating. So we'll do that copy paste one more time. You can select that surface on the bottom side of the cold runner. All right, select all of the elements. Check mark. And then we'll select the geometry, which we'll probably have to do from the model tree. And then once that's selected, you can hit the green check mark. And you should see a bunch of green elements actually now. Those are actually overlapped with one another. So the last step here is to delete all of the overlapping mesh on this surface. We're going to delete all of the overlapping mesh, and then we're just going to stitch those 2 meshes together. So what I'll ask you to do is actually, we're going to select the two surfaces that are attached to the poly surface. You
Okay.
should have the bigger surface, and then you should have the smaller surface. Okay, and then we can right click and show selection only. It'll just make our life a little bit easier, only having those two. What we're going to do here is we're going to delete all of the surface mesh on this larger mesh. We're going to delete all of the surface mesh that overlaps with the runner. So we're going to do that is with the create surface mesh and delete, not the delete selected. So not this guy. We're going to use delete, select the surface mesh. That's going to be the larger of the two, check mark. And it's going to ask you which elements you want to delete. And effectively, and this is where this blue color really comes in, we're going to select all of this, try to select all of this blue mesh. It's actually okay though if we select a little bit more than that. So what I'm going to do is I'm going to box select most of the mesh, maybe up to like this boundary. Maybe I'll leave one element of gray, or one layer of gray elements here. And then using control, if I hold the control button on my keyboard, I can actually box select and deselect elements that I don't want to be included in this. It doesn't have to be incredibly precise. It's just the more elements you delete here, the less elements you have to recreate. So the most important thing here is that we delete all of the elements that are highlighted in blue, because those are overlapped with the mesh that we created. Go ahead and press the green check mark, and that'll get rid of those elements. So what we're going to do is, and this is a technique in surface meshing called bridging. So we have one mesh here, and then we have one mesh here. We're going to create a bridge that connects the two meshes. So we're going to create two elements. One element is going to have the base on this mesh, and one element is going to have the base on this mesh. So it's going to be two triangular elements like this. One's going to be connecting 1, 2, 3 nodes. The other one's going to be connecting 1, 2, 3. The reason we have to do that is because there's a function that's called fill hole to connect one continuous hole of surface mesh. But in order to have that, right now we have two loops of edges, and we don't have one continuous loop of edges. To enable this, what we're going to do is we're going to use the sketch function. So under create surface mesh, we're going to use sketch. All right, and actually here we're quite literally just drawing the surface mesh elements. So we're going to draw the 3 points of the triangle. So I'm going to draw 1, 2, 3, making sure that 2 of the points are on the inner mesh. And then the second element, I'm going to go 1, 2, 3. It doesn't actually matter the sequence that you click, but the most important thing is to make sure that this second element has the two nodes on the outer mesh. In the edit surface mesh section, you should be able to go into the fill hole function. And when you open up fill hole, it says select a closed edge loop. So we're going to select the inner surface mesh, or the kind of like that red surface outline. All right, and then you can press green check mark. This part is sometimes important, sometimes not important. I usually like to go through this. So what it's asking is, it's asking us to connect the dots. So for example, if I wanted to retain a certain region of my geometry, let's say I wanted to make sure that there was a node connection here, what I could do is I could select 1, 2 nodes, and then it'll create the surface mesh up to that point. And so just to make sure that I don't have to do this multiple times, I usually just go in this, but for like I'll say this is relatively rectangular, like I'll just go to the 4 corners. And I'll just click the 2 dots kind of near those 4 corners. You could go like an intermediate point between the two. And then once you're ready to finish it, you can just press enter, and it will fill in the rest of it. So now that we have one continuous mesh, we're going to combine all of this mesh, and then it's just a matter of mapping it to the bottom surface, and then creating the mesh between the two. All right, so let's go ahead and combine all of this mesh. So go ahead and press the and box select. You can box select everything on this surface. All right, so let's go ahead and select all of that surface mesh, and then we'll hit combine. All right, check mark. All right, and then I'm going to map this surface mesh down to the bottom side. So we'll go map to face. It looks like 14 in total. Okay, so the last step here, we're going to create the mesh between the two under where I think your dropdown should say create by sweep. So under that dropdown, you'll hit create by two faces. All right, start mesh is the top one, and mesh is the bottom one, and then 3 points on either. It's the corner. 2, 3, 2, 3, and we'll use the 10. And then we can go ahead and attribute this as the part, and we'll call it as apply to, matching the rest of the geometry.